Myself, Chetan Jadhav. I am a research scholar in Department of Chemistry, Dr. Babasaheb Ambedkar Marathwada University, and I am doing the PhD under the guidance of the Dr. C.H. Gill sir. And today I am here to present the seminar research topic, the greener protocol for the synthesis of potentially active heterocyclic compounds. The objectives of my study is to develop the greener methodologies in multi-component synthesis and by using the ionic liquids and biocatalysts, and another aim is to find the bioactive compounds for the cure the disease. The chemistry is the undeniably a very predominant part in our daily lives. The chemical development also bring a new environmental problem and harmful unexpected side effects which results in the need for the greener chemical products. To develop the greener and safer methodologies and compatible with the environment by using the all 12 principles and by follows the all 12 principles in the organic synthesis is our aim. To eliminate the volatile and additional catalyst. The volatile solvents is very harmful in nature. They are carcinogenic in nature and they harm to the human being. That's why we can avoid it and we can choose the ionic liquid for the synthesis of the organic moiety. The ionic liquids is the air and water stable and easy to prepare in the normal condition. And another applications of my work is to find and synthesis of biologically active heterocyclic compounds to cure the harmful disease to the in human being. In our proposed work, we are working on the multi-component reaction. The multi-component reaction in which the several reactions are combined in one synthetic operations have been used to extensively to form the carbon-carbon bond in the synthetic chemistry. Such reactions offers a wide range of the possibilities for the efficient construction of the highly complex molecule in the single step procedure, thus avoiding the complicated purification procedure and thus can be allowing to saving the both solvents and reagent. Thus, they are the perfectly enabled to automation for the combinatorial synthesis of the organic molecule. In the past decades, there have been the tremendous development and four component reaction and great efforts to continue to made the develop to the new MRC in the recent trend of our work. The multi-component and multi-step reactions comparison are here. The multi-step reaction, there are the divergent reaction pathway are there. The side product formation rate is greater to the multi-component reaction, and one step to the another step there are the low efficiency of product formation and the low diversity per step is there. But in multi-component reactions, the convergent reactions are there. There are the PQR, there are the reagent, and these reagents are in the one pot, and formation of the desired product is very efficiently and the high diversity per step in the multi-component reaction. The multi-component reactions always predict and always achieve the ideal reaction condition. What is mean by the ideal? The ideal reactions is very simple workup procedure. There the productivity is the 100% and ready available starting material used for the synthesis of the organic molecule. They are the eco-friendly in nature. Why eco-friendly? Eco-friendly means there are the no pollution and the no byproduct formation in the multi-component reaction and very resource effective for the formation of the finalized organic compound. Another one in the green catalysis. Green catalysis we are using the ionic liquid for the synthesis of the biologically active heterocyclic compound. The ionic liquid made up of some common cations and anions combine with each other and they forms the salt, and salts are the, liquid at the ambient temperature, have very stable range in over the 300 Kelvin, a very low vapor pressure at the room temperature, and the selective solubility of the water and organics. The most important application of ionic liquid is it replace the volatile organic solvent. The organic solvents are the carcinogenic in nature and they are harmful to the human being. That's why we can avoid it. The ionic liquid not only act as the solvent but also catalyze the most organic reactions in the multi-component synthesis. In targeted outcomes, in the first slide, we can show that the rapid multi-component tandem annulations of the ionic liquid, a convergent access of the N-alkylated pyridine as the anti-cancer scaffold. In this, we can use DBO acetate for the synthesis of the N-alkylated pyrimidine over the 30 cases with the wide substrate variations. We can choose the mild reaction condition, operationally very simple, broad substrate scope, and the main application is that the no column chromatography used for the workup in that workup of that N-alkylated pyrimidine. The second one is the formation of the dihydrothiophene uriformides by using the DIPASE, that is the diisopropyl ethyl ammonium acetate, is the ionic liquid we get prepared in the normal condition and the formation of the dihydrothiophene uriformides at a room temperature. There are the 39 cases with the wide substrate variations in that scheme, and the low and the less toxic solvent used for the formation of that moiety, and the cheap, sustainable and reusable catalyst. After the fifth cycle, we can use this catalyst for the formation of this moiety. The high atom economy and E factor gives by using the DIPA in the synthesis of the dihydrothiophene uriformides moiety. Then another one slide, then third one is the highly functionalized imidazole synthesized by the DBU imidazolate ionic liquid. The DBU imidazolate ionic liquids used in the various organic transformation. That's why we can use in the synthesis of imidazolate, highly substituted imidazole, with simple mild reaction condition, operationally simple, and no column chromatography used for the workup procedure in synthesis of the highly functionalized imidazole. Then another one is the pyrimidopyrimidine synthesis by the ETNS3SO4 by using the 1 millimole at a 60 degrees Celsius. That is high yield are there. That is the 94 to 96% of yield, and the wide substrate variation, that is the 39 cases with wide substrate variations are appear. And simply there are in the application of that reaction, there are the most eco-friendly and inexpensive promoter and solvents used in that synthesis. Then the last one is that the pyrenoquinolone synthesized by using the biocatalyst, that is the beta cyclodextrin, as the supramolecular catalyst for the synthesis of the pyrenoquinolones with the wide substrate variation with the 20 cases, and at ambient temperature and using the ultrasound radiation, that is the approach for the green chemistry. Here we can done this targeted outcome in our research work. I am very thankful to the Dr. B.B. Singh sir, departmental coordinator, to providing me the opportunity for giving me the presentation on my research topic seminar work. And thank you so much.